A database will have its own certain characteristics. Based on for what purpose we want to use a database, we may employ different techniques and different tactics we might use to design that database. Today we will discuss about how to design data warehouse and data marts. We have certain expectation from a data warehouse or from a data mart. We have a certain set of expectations. Primarily, those databases should fulfill those expectations. If you look at an information system, you may find many applications, and then like you can see many applications, then many databases. Also, if you look at these applications, categorize them, you will find two different class of applications. One, what I have encircled with the yellow, are transaction processing applications that effectively automating the business process. We call it online transaction processing application, OLTP applications, on online transaction processing. So actually business process automation is the responsibility of these applications. Another class of applications that are used internally by the organization for reporting and analysis. They are normally used by executives to look at the business, to gain insights. By looking at the trend of the business, you can take better decisions and then also make sure that your organization is functioning effectively. For that, you may need report and business data analysis. For that, we will use a set of tools as well. These also works with database. Initially, if you look at information systems some years ago, or even today in many organizations, they will have same database to serve both purpose, to serve the reports, to serve the online transactions. For everything, they will have the same database. If it is a very small sort of an organization enterprise where not much data is generated, then there is no big issue. You can use the same database for both purpose, and this is more effective in that situation because these databases are easy to manage, and then there is no a huge amount of data, and when this application works, it will not create any performance issues to these applications. Then it is good. This architecture is good. But when you have an organization which produce a huge amount of data, initially you might find everything good. After some time, you will have more data in the database. In order to do anything with the data, you will have to read at least database server has to process a huge amount of a big data sets. What eventually will happen, server's ability to process that data will diminish, and then its response to these applications will be very poor. So that means all applications will suffer from server performance. And then this issue happened practically, and then people started finding the solution for that. The solution was to move that data to a separate database. Keep those databases. These are transaction supporting online transactions. So keep these databases slim and efficient enough to support all the actual business process automation or business operations. So keep these databases lean enough to support them. And at the same time, when you have data accumulated in this database, periodically you move that to a separate database. If you look at this separate database, you can definitely understand that data is coming from many systems, and it keep on coming here, and it will get accumulated. So a huge amount of data will be generated here. After moving or purging data out, this will become still very operational and very slim. And this type of an architecture was evolved. And we call this database as a data warehouse database. This is the data warehouse database. The wall kind of extracting data from here, and then any kind of integration activity you do in the middle, and then load those things. In generally, we call it as a data warehouse. Everything related to this particular activity, we call it data warehouse. Once you have a huge amount of data in a warehouse or in a database, it is going to be a very good source of information. So we can use reporting and analysis tools to analyze the data available here. Those data analysis will help you to take very good decisions, because we know how business is going on in various places, in various climates, in various situations and time. And then you can look at and analyze it. Instead of just relying on your intuition, you can look at the actual data and take very effective decisions. So the entire ecosystem was developed around the data warehouse database. And this particular space is called ETL, extract, transform and load. There are many tools available in this space, like Informatica and Oracle has tools here. IBM has got many tools, data integrator and or data loader sort of tools.
Yeah, IBM is data stage, right? And Oracle is ODI integrator.
Yes. IBM data stage. We have many tools from many organizations. Sometimes they do all the things and sometimes do one by one each thing here. Even if it is one tool, there may be different components to do extract. You may not be directly connecting to these database so often, right? Because these databases are supporting the operations. So this database, what you may do is just save the data last month as a CSV file or in a text file. You use some separator, maybe pipe or comma separated or whichever format based on the operating system where it is deployed. You might use different symbols to separate. But anyway, data you will extract from here to some file, and from here you will read this file and then load that data to this data warehouse. So before loading, you may cleanse the data, you may change the format, you may substitute correct or approximate values for null, and all those cleansing and transforming the data activities we do here. For that, there are many tools. And then finally, we update, insert that data into this data warehouse. So load that data here. So extract, transform, load is an activity we perform here. In this process, we may use a lot of staging servers. We keep the data somewhere in the middle and do some processing there, then move. We call them as staging servers. Infinite staging servers are possible. There are implementation where there are no staging servers, just load and in some SQL you do the processing and cleaning and then load there here without an intermediate database. That is common. And also using one staging server is also common. And then pre-staging, staging, post-staging, that way many different layers of staging is also common. So it is all depends on how complex your data is, how simple your data is, how much cleansing or how much transformation you have to do in this layer. Okay. So this is the story of the data warehouse. And then for this database here, there are many different databases. And one class of databases, we call it appliances, like Netezza. If you buy Netezza is exclusively made for data warehouse database. Teradata is another data warehouse database. Actually, they have developed those databases which is to address data warehousing challenges, working with a huge amount of data and then running queries which are going to access very big data sets. These are the issues very specific to a data warehouse database. So Teradata, Netezza, Greenplum, there are many databases. They exclusively focus on developing databases needed to support data warehousing needs. Then SAP HANA, if you know, that is also an in-memory database. It can work with a huge amount of data. Now that there are even implementations of Hadoop or any kind of NoSQL databases, they can take huge amount of data and then keep it. Okay, we have data warehouse, and then this data warehouse, once we have data, we will be using them to analyze. For analysis of data, there are many methods. Okay, I'll just tell you one simple method is you create views in this data warehouse. Okay, we have loaded a lot of information here. We have many tables and their relationships, and then analyzing data from there may be a little bit difficult. So you can create views, and you may not want to provide access to the core data for everyone, right? So whoever want to analyze specific data, if they have permitted to that, you create specific views for a particular user or a class of users, and then grant them access to, and then they will analyze data from that views. They will use a front-end application to read data from the views, but you will have a security layer here to create a view and then expose information. Views has got its own merits and then challenges, because views are, again, it will read data from the base tables. And then if you keep on reading data from the base table, again, there will be a lot of resource consumption at server. Then databases came up with materialized views. There are views, once you refresh that view, it will keep data, like just like a table it will keep. Let's say base tables are here. It will not keep on going and reading it. It will, once in a while, it will refresh. You have to set an interval for refresh. Let's say refresh once in a day or twice in a day you configure, then it will refresh from the actual data. So only once or twice it might read from the actual data. Then it will keep the view here. Sometimes what we will do, we will aggregate the data. Last 10 years of information you have in the data warehouse, right? Again and again, each time you need, you may not want to aggregate that to, you may not want to read that to aggregate. So what we will do, sometimes quarterly data we will aggregate and keep it in separate tables. So you in a data warehouse, you may find the actual core data, and you may find the views, you may find the aggregated data, materialized views, and so many other objects which supports data analysis.